Recall from first semester that the difference between a polar and a nonpolar molecule is all about electronegativity and molecular shape. So, for example, in water molecules that are shown here, oxygen is bonded with two hydrogen. Oxygen has a really high electronegativity, which means it's very good at attracting electrons, while hydrogen has a lower electronegativity and is not as good at holding electrons. Water also has this shape where you've got one oxygen and two hydrogen, and that shape is called bent, if you recall from first semester, because it is asymmetrical or not the same on all the sides. This allows this molecule to be polar and have slightly positive and slightly negative sides. So in the case of water, oxygen is slightly negative while hydrogen is slightly positive, and this allows these attractions. Another attraction that happens in water is something called hydrogen bonds. Again, they're not really bonds, but rather very strong intermolecular attractions. The negative end of the oxygen is attracted to the positive end of the hydrogen in all the water molecules near each other. And this occurs because hydrogen is very small, and so is oxygen. Hydrogen bonding can occur with hydrogen, nitrogen, oxygen, and fluorine, all of which are very electronegative small atoms. This all amounts to water having some very unique properties. The first property is high surface tension. It's really the ability of water to stick to itself. It sticks to itself so much that it has what's like a skin on its surface. You have seen evidence of this if you've ever done a belly flop, or if you've ever witnessed a water strider sliding across a pond. There's even a lizard nicknamed the Jesus lizard that can appear to run across water. This unique ability of water to stick to itself can cause some issues when it comes to cleaning clothes, for example. So detergents have to be designed to break apart this skin to get at the stain on the clothing. A couple other examples of surface tension on water are on the left here, the metal paperclip balancing on water. If you had me for freshman bio, we did an intro chemistry of life unit where we balanced some paperclips. Some students were able to balance even 7 paperclips on that surface tension of water. Another example on the right here is you can see this close-up picture of the water droplets that look like beads on this leaf. Water also has a very low vapor pressure and a high boiling point, and that's going to require a lot of energy and heat to make it evaporate or boil. The third property of water is the specific heat. If you recall our specific heat unit, you'll remember that water has a specific heat of 4.184 joules per gram degree Celsius, which is much greater than most other things. Metals, for example, are all usually under 1. And so that means it takes a lot of heat to change its temperature. It's why heating the water in your house is one of the most costly things. It's also why we've all likely experienced this common everyday occurrence when we went to eat a fresh, hot piece of pizza. So you go to pick up the pizza and you touch the top of the cheese and it seems like, okay, it's cool enough. Because the cheese is cooled off, and you take a big bite, and as soon as that bubble of sauce hits your mouth, you scald your tongue, and then you don't get to taste the rest of the pizza. So the reason this happens is because the cheese has a lower specific heat, and so it cools down faster. Pizza sauce, it's mostly water. It has a high moisture content, and so basically it's got the specific heat of water. So it stays much hotter for longer. And so that's how you burn your tongue on that sauce, even though the cheese was cool enough to eat. Another case of this is ocean breezes. Ocean breezes occur because the land has a lower specific heat than water. And so the land will heat up quicker than the water at the ocean. And so because of this, you're going to have a difference in pressure. And we have difference in pressure. We know that things are going to move from high pressure to low pressure naturally. And so this causes this ocean breeze to come in. And it flows from the water to the land. In Chicago, because it's on the Great Lakes, the lakeshore keeps the temperature at the lakefront cooler during the heat of the day. This happens in the reverse at night, however. At night, the land cools off much faster than the water, and the temperature is therefore it's warmer at the lake front than at night because this heat coming off of the land is warming it, as the heat coming off the land is now going back out, as shown on the top here. Another unique property of water is the hexagonal six-sided shape of crystals in ice or snow. If you've ever made a snowflake as a kid, you've seen this, or if you've ever looked up close at a snowflake, you'll see that it has this unique ability. And this is all due to the hydrogen bonding and the polarity of water. Water is also the universal solvent, and it readily dissolves other polar substances such as salt, ionic salts, anything that has positive and negative charges. Water is very good at breaking it apart. And so a lot of our solutions that we use in chemistry are aqueous